Hello, George.
Hello, how are you?
I'm doing well, thanks. How are you?
I'm good. I'm all right. I'm way up here, hanging out with the magpies on the top of our university here, bell tower
Nice.
behind us.
Looks like we're both up in our office penthouses.
That's exactly right. Right where we should be, right where we deserve to be,
Exactly.
because of all the decent work we do.
I love
Right?
it.
Don't you think so?
I think so.
I think so too. I think so too. But enough patting ourselves on the back. Okay. So I saw something. It was really like kind of nifty, and I didn't know. I don't know if it's something that I can use, like in a general, like I can use generally. So can I share it with you?
Absolutely.
All right, let me see if you agree with this. If I asked you what 16 divided by 64 is, what would you tell me?
Oh, well, that's a quarter.
Oh, cool. Yeah, right. I agree. A quarter.
No.
I totally agree with you. Yeah, cool. All right. So now I got a totally new way to
No, not like that.
why? What's wrong with that? What?
You can't
I got the
cancel that.
right answer, didn't I? What, do you have something to tell me about this? All right, I guess. I don't know. Well, how are you gonna tear it apart? You're a mathematician, tear it apart, right?
Oh gosh. You can't
What's wrong with
cancel
that?
it like that.
Come on, it makes life so much simpler though, doesn't it?
It does. That seems like a bit of a hoax, though.
Yeah, a little bit. It's not gonna fly in every situation.
No. That's
Sorry.
That actually reminds me of a topic that we can talk about today. Have you ever heard of mathematical fallacy?
Well, yeah, I have.
Mm.
So how does this tie into it? Like, what
Um,
happened?
well, this is where a mathematical proof, sort of falls apart and doesn't really reflect reality. And it's different to a proof that's failed, because a proof that's failed, that something has gone wrong, but a fallacy, that's where, well, something hasn't really gone wrong, but it still doesn't give us what we want.
That's right. That's right. Somewhere where we may have made a step that maybe we shouldn't have made, that maybe kind of is kind of makes the whole thing fall apart. Maybe we're like missing some kind of foundation there, something that we didn't really, I guess, didn't really take account for, possibly. All right, yeah, it sounds fascinating. You got some examples?
I do. Let's share the screen. Technical difficulties, guys. Give me just a sec.
That's okay. We got patience around here. Do that.
All right.
Beautiful.
Has this turned up?
It's looking good. It's a whiteboard. I see a bunch of markers on the bottom.
Yep. So this is my handwriting debut, guys.
So let's see. Yeah, I'm going to be very critical because you know my handwriting, how beautiful it is.
We'll see. We'll see whose is better. We'll get people to vote.
Right, no kidding. Well, I know how that one's going to turn out. I already know, and I haven't even seen anything you've written. So,
oh, let's see. So, well, I'm going to start by having 0. Oh gosh, what's going on here?
That's not a good start.
That's not a good start. Hang on. I tell you what, this pen it's a little bit strange. It wants to go sideways a lot, but not very up and down. There we go.
Oh, that's good.
And I'm going to make that equal to 0. Do you agree?
Right. Fair enough. I totally agree with that.
Yeah. And, well, in fact, I'm going to say that is 0 plus the additive identity. Would you agree? Which is 0?
Yeah, I agree.
Yeah, so
when we say additive identity, we mean what do we add to something to get exactly what we started with.
Yeah, exactly. Yeah. I think it's one of the calculus axioms, I think, is it?
I think it is.
Yeah.
All
and
right.
In fact, that can continue forever. We can add as many identities as you want, and it's still gonna.
Yeah, I could agree with that.
Yeah.
Seems a little bit, I don't know.
Yeah, this seems a little bit basic.
Yeah.
a bit straightforward. We're taking a very simple thing and making it quite complicated. But there's a reason why. And in fact, let's go over here for a sec. What is the identity equal to? We can have any number plus the negative of itself. Would you agree?
Yeah, absolutely. Yeah.
Yeah. So so this 0 here, this is 1 plus minus 1.
Yeah, I can agree with that. No problem.
Yeah. And so is that 0 actually, 1 plus minus 1.
Okay.
Plus forever, because this is an infinite sum and this is yeah, the same.
Mhm.
And I believe it's actually one of the calculus axioms as well, which is associativity. Have you heard
Okay.
of, yeah? It's where
Right.
we can move these brackets around and it's still going to be true. And in fact, I'm going to move this bracket over here.
Okay.
Would you agree?
Okay. I see. So you haven't really, so you've gotten rid of those first outer parentheses in that first term of the third line, right? And then you're just grouping that first negative one with the second positive one.
Exactly.
Yeah.
So it's like I'm taking these brackets here and just move them along a bit.
Okay. Yeah, I can see that.
We can also write this over here as this. You know, it's just the same. It's just got the other way around.
I think you're using the commutative property there. And
yes, I would agree.
I think you're using the associative property on the bottom bit.
Mm.
You're just grouping them in a different way. You haven't really rearranged them,
Mhm.
but both apply, and you can use either one if we need to.
Exactly.
Because I thought you were going to add all of the ones together and then add to that all of the negative ones together.
I certainly could, but in this case, in this instance, I'm just moving the brackets around.
All right. I'm totally with you. I agree. I don't see a problem yet.
But we actually know what this is equal to. This is 1 plus 0, right? Because what we got over here.
Oh, because you're grouping those other bits.
Yeah.
Something happened here, didn't it?
Yeah, and if that one's 0 as well. So there's another 0. And that's that infinitely, except
so now we end up with what? 1 equaling 0, 0 equaling 1.
Yeah, and this is totally normal, right? This is completely legit.
I don't want to believe it, because I got to go back, and anybody that I've taught that 0 doesn't equal, when I got to go back and get a hold of those people and let them know that it actually does. I hope something went wrong here.
Something did go wrong here. Can you guess what it might be?
You know what? Here's the thing with this. I think I may be wrong on this, but I think we can't automatically assume that things that happen for a finite set of numbers happen for an infinite set of numbers.
Yes, absolutely.
I think that's the bit, right? Because I mean, you can also, I guess, say you add up all the ones and get infinity plus negative infinity equals 0, then it starts. I guess you can even come up with that type of proof, that infinity minus infinity ends up equaling 0, but that also has issues, I imagine.
It does.
Yeah. So with just a little bit of, one particular condition not being in place that you might assume, like in this particular case, you assume just because it's true in the finite case doesn't necessarily mean it's going to be true for an infinite series, as kind of like you set it up. Very, very clever.
This is true. And what I'm doing here is I'm just rewriting it. Instead of ones, I'm going to be using x and minus x.
Okay.
And the reason why I'm doing this is because it's going to be showing how the proof should have gone. So this sum is only ever true when x equals 0.
When x equals 0. Okay. Very nice. Very nice.
There we go.
Very nice. So that's okay. So there's certain things that we can do, and we think that we've done them correctly, and then just one small detail kind of makes everything fall apart.
It certainly does. Yes.
All right. Well done. Very nice.
So I'm going to try and rub all this out now. And I've actually got another one to show you if you'd like to see it.
Yes, absolutely.
So
and I want to mention this.
Yeah.
Your handwriting's getting better and better as we move along.
Thank you very much.
Truly, I'm not trying to, I'm being honest. So
thank you very much.
Oh, you got all kinds of cool pen types.
Yeah,
too,
this is great.
Very nice.
Ooh.
Very cool, man. I should start using whiteboard instead of the Zoom equivalent.
I didn't realize until we started today that Zoom actually has a built-in whiteboard, so I just got my own up from.
All right, well that's good. No,
from down here.
I tell you what, you may have convinced me to start using this as opposed to the Zoom app or the Zoom feature, the whiteboard that comes along with Zoom. No, nothing, no malice against Zoom, of course, would be appreciated.
Of course, yes. We love the contributions that Zoom has made to society.
No kidding, absolutely. They could come up with a copy and paste function though on their whiteboard. That would come in so handy. Anyway, I'll send it into their customer service department.
Absolutely. We'll write in after this.
All right, please continue. Please continue, Laura.
Right, so I've got here, let's put A equals B, right?
All right.
We've got two variables, we're going to make them equal to each other. And we're going to multiply both sides by A.
All right.
Right?
All right, I'm
so that's going to be AB.
Okay.
Okay, but we know what A dot A is, that's just A squared.
I agree with that.
So that's AB. And what I'm going to do now is just take B squared from both sides. Oh, goodness me. I pressed a button there.
That's okay. Yeah, sometimes that happens. I have the same issue.
I didn't mean plus, minus equals AB minus B squared.
Okay, that's cool. So far, so good.
But we can factorize both of these sides, right? So we're going to have A plus B, A minus B.
Okay.
Right? If I've done that correctly, I think so.
Absolutely, absolutely.
That's good. And that's just B, A minus B. Cool.
Yes.
But, cancel both.
Okay.
On both sides, we can simplify this. A plus B equals B. Nice.
Okay.
But we have up here at the top, we've already defined A to be B. So this is just B plus B equals B.
Okay.
So 2B equals B.
Oh no.
And therefore 2 equals 1.
2 equals 1.
Right.
Didn't you know to stop at 0 equals 1? Now you want 2 to equal 1?
I just love everything equaling 1.
Man? What did you do? Let me ask you a question, okay? Because there was always some kind of, I don't know if you follow the rules when you were told a bunch of rules way back when we started learning math. But one thing was you were always told never, ever, what?
I don't know. You say.
Divide by 0?
Yeah. Yeah, something's gone wrong here.
That's sneaky, man. That's sneaky.
So where have we divided by 0?
I think if you say, I think on the division by the B.
Division by B, is that here?
I think so. I think the division by B. I was basically looking, I'm just saying to myself, okay, where can we run into trouble? Division by 0. So as soon as I saw that division, I got a little bit uneasy.
Yeah.
So can the same thing be said? I mean, it's true. If B is 0 and A equals 0, that A equals B. I totally agree. But if you put in the condition that they're not equal to 0, you're not able to take that last step.
That is true. However, we've actually gone wrong a little bit before that.
Oh, really?
We
Okay.
have, which means that we don't need to make a b not equal to 0. Because there's something else that we've done which we can't do.
What's
And it's
that, man?
here,
Really?
a minus b, because we've already got a equal b, which means that
But
a
you've
minus b.
multiplied by 0. Wait a
Yeah.
minute, is that right?
So when we factorize this, we've got this multiplied by 0 equals this multiplied by 0, which means we would have a 0 equals 0 equation, but we can't cancel both sides because we can't divide by 0.
Okay, all right. Yes, yes, yes. You basically took something and made it universally true by multiplying both sides by 0.
Mm-hmm.
I got you. So you basically wiped out whatever information we had.
Yes.
And made it all equal to 0. Okay.
Mm-hmm. So
wow,
this
okay.
means that this proof here, this isn't a mathematical fallacy. This is just a false proof. And it's because of this line here that it doesn't happen.
You basically take, and I think, in fact, now that you mention that, lots of times when they'll give us a, I'm gonna see if I can annotate here, okay?
Cool.
Maybe they can look at, people can see and tell us whose writing looks better next to each other, okay? I think if you say that, if you said that A equals B, right?
Mm-hmm.
And then if you want to show I'm not sure exactly what the property is, but the multiplying both sides of this equation by the same thing gives you an equivalent equation.
Mm-hmm.
So we always say that AC equals BC, but we always show the condition that C better not equal 0. Because you might take something that's true in a particular case for values of A and B, that you made whatever values of A and B we've taken, if we multiply both sides by 0, we get a true statement.
Of course.
And now I'm convinced that you get the, you win the prize for best handwriting.
Oh, thank you.
So that was, you know what? Lots of times, I mean, people can go through these proofs and they end up seeing that, you know, getting a result that it's not quite what they expected.
Mm-hmm.
Or maybe in my case, it was something that was too good to be true. Because it'd be so nice to be able to, you know, have a number that looked like this. And then a number that looked like this. And then start doing this bit right here. Wouldn't that be a wonderful world?
That would be fantastic.
There you go. That's equal to 7/2. Now, if that's true, I'll be amazed. I doubt it though.
I wouldn't believe it.
I wouldn't. I tell you what, it'd be pretty lucky. Pretty not very probable that I picked the right number. Can I show you one thing? I'll show you something. It doesn't really have to do with this, but it was kind of scary.
Okay, sure.
Can I show it anyway?
Do you want me to?
It doesn't matter. It doesn't matter.
Okay.
I mean, it's going to take maybe 2 minutes. Okay.
Sure.
All right. So, you know what? I'll save it for another time, just so people can tune in next time. How's that? Okay.
Sounds good.
As a cliffhanger. All right. It was spooky, actually. It made the hair on the back of my neck kind of rise, but
okay.
I'll save it for our next video. Okay.
Right. Excellent.
All right. So there we go. All right. You can say a proper bye-bye to
Indeed.
everybody.
All right.
Thank you so much, Laura. This is always so enjoyable. And today was, you know, it didn't disappoint, that's for sure.
Excellent.
All right. I'll talk to you soon. Okay.
Great. See you next time.
Bye-bye.
Bye.